Okay, today we're going to be looking at section 7 or 5.2, which is direct variation. Hopefully by the end of this section, you can say I can write and graph an equation of direct variation. So to get us started, we got a little exercise here. It says the diagram shows how long it takes to hear thunder after you see lightning. The general rule, or what is the general rule, can you use to model the situation and explain? So we know that if you're 2 miles away, it takes 10 seconds to hear it. If you're 3 miles away, it takes 15 seconds to hear it. So what is our general rule? So we would be saying this. How many seconds does it take to hear it based on the number of miles? Well, if we look here, 2 miles took 10 seconds. 3 miles took 15 seconds. So the number of seconds would be number of miles times 5. So 5 times the number of miles will give us the number of seconds that it takes. That would be a general rule. Okay, so let's take a look at the next slide. So what we're going to be looking at today is direct variation. So essential understanding. If the ratio of two variables is constant, then the variables have a special relationship known as the direct variation. A direct variation relationship that can be represented by a function in this form. Here's the big idea. Y is equal to kx, and k cannot be equal to 0. So the constant of variation for direct variation is k, is the coefficient of x. By dividing each side by x, you can see that the ratio to find k is this. So big idea is this. Direct variation equation, y equals kx. And to find k, you simply take your y divided by your x. Your k stands for your constant of variation. Okay, so today you're going to be asked to determine whether something is a direct variation, and if it is, you want to find the constant. So if I look at an equation and try and determine if it's a direct variation, in order to determine that, you simply look to see if there's anything besides y's and x's. If there's anything besides y's and x's, like this plus 2, that tells you that this is not a direct variation. Okay? The next one, number 2, if you take a look at this one, all you have is x's and y's. So this is yes, it's direct variation. So now we got to find our constant. To find that constant, we know that you want to have y over x. So how do I figure this out? If you solve for y, you know that y is equal to kx. So if I can figure out what the y is equal to, I could find my constant. So for number 2, you could do this. If you add 5y to both sides, you'd have 2x is equal to 5y, or 5y is equal to 2x. So if we divide by the 5, you'd have y is equal to 2/5 x. So what's our constant of variation? Constant of variation is right there. It would be 2/5. Okay, if we take a look at this next one, the next one, we would say yes, it is a direct variation because all we have is x and y's. To find that constant, we divide by a negative 56 to get the y by itself, and you'd have a 1/8 x is equal to y, or y equals 1/8 x. So that tells you that your constant of variation is right here, which is 1/8. And for this last one, we can see that we got a plus 2 and a minus 2, but those two would cancel each other out. So really, we do have a direct variation. So 4y equals 8x. If you divide by a 4, you'd have y is equal to 2x, which tells you 2 is your constant of variation. And yes, it is a direct variation. Okay, so that's one thing you're going to have to do today. Next thing, suppose y varies directly as x. Write a direct variation equation that relates to x and y. Find the value of y when x is equal to 8. So the first thing we got to find to write this equation, y is equal to kx, we need to know what the k is. And to find the k, you simply take your y divided by your x. So in this case, I take 4 divided by 8, which is 1/2. So your equation would be y equals 1/2 x. Now to figure out what the y is when x is 8, you'd simply plug in an 8 for the x, and you would find that y is equal to 4. Those are the two things you'd need to find. So let's go ahead and do it for this one. To find that k, you take 15 divided by 3, which gives you a 5. So your equation would be y equals 5x. So there's that part. And then to find out when the x is 8, you simply put in an 8, and you have y is equal to 40. Okay, so I'll let you try and do it for number 7, and we can take a look at it in just a second. So the k would be equal to 3 divided by 8, so 3/8. So our equation would be y equals 3/8 x. So to figure out when x is 8, you'd have 3/8 times an 8, which gives you a 3. So we'd have these two things. Okay, we'll skip number 8. Next one, if we want to graph a direct variation, I'm going to show you one way, and then we're going to try and figure out a pattern. So if I plug in a 0, a 1, and a 2, and a 3. So if I plug in a 0, I get out a 0, because 3 times 0 is 0. If I put in a 1, I'd get out a 3. If I put in a 2, I'd get out a 6. If I put in a 3, I'd get out an 9. Okay, so I'd have these points. I'd have 0, 0. I'd have 1, 3. I'd have 2, 6. I'd have 3, 9. So I went over 1, I went up 3. Or you could say I went up 3 and over 1. Up 3 and over 1. Okay, so this next one, we've got a negative x, which is like a negative 1x. So if we have a 0, we'd have a 0. If we had a 1, y would be a negative 1. If we had a 2, y would be a negative 2. If we had a 3, y would be a negative 3. So 0, 0, I'd have 1, negative 1. So what's happening here? Every time I go over 1, I go down 1, or down 1 and over 1. Down 1 and over 1, which is representing this negative 1. Down 1, over 1. Okay? So if I took a look at this one, if we tried to think of this one without a table, I know that if I put in a 0, I'm going to get a 0. Okay, what's it going to do from there? Well, if you think about this direct variation, this is telling you two things. It's telling you this is going up, over. Up 3 for every 3 it goes over. Or excuse me, up 2 for every 3 it goes over. Up 2 for every 3 it goes over. So I'd have this line right here. Okay. Next thing. Tell whether y varies directly as x. If it does, write the equation of direct variation. So in order to do this, for each one of these lines, you're going to take the y divided by the x. So 5.4 divided by 4 gives you 1.35. If you take 2.7 divided by 2, you get 1.35. If you take a negative 2.7 divided by 2, you'd also get a 1.35. So yes, this is a direct variation. And the equation, here you have your constants, so it would be y equals 1.35x. Okay, so if we tried this other one, a negative 6.9 divided by 6, which gives you a negative 1.15. If you take a negative 11.5 divided by 10, that also gives you a negative 1.15. And negative 8.05 divided by negative 7 This is going to give you a positive 1.15. So is this direct variation? No. It would have been if this number down here would have been a negative. Okay? So hopefully that takes care of everything. And today my shout out goes to this girl with a really nice buck. Nice work, Demi. Okay, and that is a wrap.